Hey everybody, Brace here from LangChain, and today I'm going to be doing a quick tutorial demo walkthrough video on implementing Google Deepmind's Dramatron in LangChain JS and LangGraph. If you're not aware, Dramatron was a project by Google Deepmind from I think 2022, where they take large language models and using their flow they can generate entire plays. And there is a little GIF in their homepage which kind of does a good job of explaining how it works at a high level. So you present Dramatron with a log line. This log line is kind of like a description of the story you want, or the play you want to generate. From there, it creates a title, then it generates some characters. These characters have descriptions. After generating the characters and the title, it generates the scheme or the plot, which contains scenes, scene descriptions, places, what they call beats, plot elements, and whatnot, and then generates, including in the plot, it generates locations for those scenes, and then once all of that is generated, it goes and generates a final dialogue, and puts it all together into what will eventually look like this. So at the end of this tutorial, when we've finished implementing all the code and we've executed it using LangGraph, it'll log our play, which looks like this. So it has a little heading, script description, different scenes, and then the actual dialogue. And as you can see, it's pretty in depth. It generates a lot of content, and it does all of this using a large language model. In this tutorial, we're going to use Anthropic, their new models, and does it all without function calling. It's simply prompting and then a tiny bit of parsing on the end. So to start, you're going to want to go to my Dramatron template repo. There's a lot of kind of code which doesn't really matter, but you need it, and I've already implemented that just so you don't have to implement that busy work. You're going to want to copy the get URL and go and clone it. So clone. Once you've cloned it, navigate to the directory and install dependencies by calling yarn. Next, you can open it up, and you'll see this is the structure. So it's a monorepo based off of a monorepo template I have. We deleted the front end because we don't need that. We're only using the back end. And then inside the back end, source directory, in example, environment variables, you're going to want to set this with your own Anthropic API key and your Langsmith keys for tracing, so you can see how your app's working. And then inside here we have 4 folders at the top and then a few files. Quickly to go through, entities, these are the different entities that the app uses, so characters, plots, titles, stories, and whatnot. And these are different classes which essentially are just going to hold the character name, the character description, or characters plural description, and they usually contain 1 or 2 methods for doing things like passing in the generated text, splitting it out, setting it into the class, and then you can access it all later, and it's not just a straight string from the LLM. So if we look through character and characters, place has this as well, format name from string, my prefix and whatnot. Yeah, so I already implemented all this. It's kind of busy work, it's really the same thing with slight tweaks many times over. Scene, scenes from string. And then as you can see inside a lot of these, we're using these constants called place element, plot element, beat element. These are also implemented inside the constants file. And here we can see all these different constants: end marker, stop marker, character marker, and these are used in the prompt. I can show that right now. The prompts live inside the prefixes directory. There are 3 main prefixes: custom, media, and sci-fi. Custom is kind of just the base implementation, allows you to customize it. Media and sci-fi are both prompts from the to prefix this. Custom, media, sci-fi. These were all ported from the Dramatron repo. That would be a lot of porting to JS if you did it yourself, so this is something that I quickly did beforehand. They are way down here, and these are essentially the prompts that we're going to use when we're calling the LLM to generate. And then these different markers, that's what they're called, kind of split up like the character, the description, and then logline. So then when we're actually calling the LLM, it sees these patterns that we use in the examples and will respond with those patterns as well. So it's easy to parse out their response without needing to use function calling. In this example, we're going to use the media one. It looks like this. You can take a look at it if you would like. But it's just a few different prompts which contain the characters prompt, scenes prompt, setting, title, and dialogue. And these are the different steps we're going to take when generating. So we're going to generate the title, we're then going to generate the characters, generate the scene, the settings, and then finally the dialogue. After the prefixes and entities, we have this system prompt file, which we can actually go do right now. This is just going to get appended to every single LLM call you make. So you can, this isn't too important, you kind of make it whatever you want, but for this we're going to use, you are a brilliant storyteller. Respond to the user's query exactly without exactly. That's enough. And then here we're going to import this into our generate file where we'll go next, where we actually generate the LLM responses and prefix this to every single LLM call, just as a kind of base system prompt. Next, utils file folder, 3 files in here. The render story is also implemented by default, just because this is rendering the story once it's all been generated into this nice string that you saw here. And this is not really specific to Dramatron. It's just a lot of pushing to an array and then joining at the end. So this is all already implemented, and it kind of gives it the structure that you saw in that example story file. The next 2 files are prefix summary and strip end. We'll implement these later. These are going to be used as little utils after we generate, before we generate, and whatnot. Diffs, these were also generated. We will come back to this. This uses a diff library, which is similar to a diff library that they use in Python. We'll get back to this when we actually use it. The generate file, I have all of the functions and the interfaces pre-built, but the content or the actual core functionality is not there, so we'll do that after. Graph, this is where we're going to define our LangGraph graph with all the different nodes, calling the generations, iterating and kind of stepping back or forward based on what has succeeded. And then we'll run it from the index file, and finally the story generator file, which contains the story generator class. This is where the core functionality between generating the title and the characters and whatnot will go on. I'll explain all of this when we get to it. This is the one method we really care about, step. It's what we're going to call inside our graph. And step will then call all the different generate functions we write. And yeah, I think we can get started on implementing it now. Alright, so the first function we're going to write is the generate text function. Inside this generate file, all of the generate title, generate characters, generate scenes, functions, they will all call the generate text to actually call the LLM and generate. And then these individual functions will just do extra things like putting together the prompt, parsing the output, returning a title entity and whatnot. But they will all come down to just calling this generate text to generate the initial text. So we can see our input is a list of prompts, an LLM, and an optional seed argument. So we are going to want to first define an output parser. We always want to return a string, so we'll just use the string, can't talk and type, output parser will always be a string output parser, which we can import from LangChain core, like so. And next, our prompt, which we can use to pipe to our LLM using the LangChain expression language, and then pipe the LLM to the output parser like this. And I'll explain what that's doing once this. So we can define our chain saying const chain equals input dot generation prompt dot pipe. we're going to pipe that to the input.llm. And it's because it's an array. Sorry. So we need to do const prompt equals chat prompt template dot from messages, pass in our prompt there, and now instead of this being an array, it'll just be a single prompt that we can pipe to our LLM, and then pipe this to our output parser. And what this pipe method is doing, essentially, it's all the LangChain expression language, so any class which extends from the runnable class has access to this pipe method, and then they all also have access to invoke. So what pipe does is when you invoke the chain, it's going to call invoke on the prompt, which will format the prompt into like a string for the LLM, and then once it's formatted, it'll then pipe it to the input of the LLM invoke call, invoke that, take the output of that, and pipe it to the input of the invoke call in the output parser. And just real quick, we can see that they all have invoke. So output parser.invoke exists, LLM.invoke exists, and so on for the prompt. So now that we have our chain, we can just get the response, say const result equals chain.invoke. And since our prompt none of our prompts will have input variables, just pass an empty string as the input, and then don't forget to pass our config object as well, and then we can return this, and we can see it's of type string because of our output parser. And now inside of all of our different generate XYZ functions, we can call generate text, and it's a simple wrapper around the LLM for always generating the text. All right, next we're going to want to generate the title, and we can see from this input we take in a storyline, which is the sentence, a couple sentences describing the play you want to generate, prefixes which are going to map to our prompt, or which is a map with our prompt, and then the LLM and an optional seed argument. So first we want to construct the title prompt string, not the actual LangChain prompt, but just the string which will go in the prompt. So we'll say const title prefix equals a template string, and we're going to take, that's almost right, we're going to want to take the prefixes that are passed in and get the title prompt, a lot of space, pass in the storyline, and then from our constants we want to add in the title, all caps, title element, and this is just going to be title colon, and it's kind of prompting the LLM to say, okay, at the end of this prompt, title, but missing title, so the LLM will continue it with the actual title that we want. And then we can put it into a LangChain prompt, say const title prompt equals chat prompt template, and we'll say from messages and pass in our system prompt that we defined earlier. So system and system default, and then right beneath that we can do human and title prefix. System default is already a prompt template, so we don't need that. We can just pass it there. Now we have our title prompt formatted as a chat prompt template. We can actually go ahead and invoke our generate text. So we can say, or we're going to need to edit this later. So let title text equals, and then await the generate text function, passing in our generation prompt, seed, and LLM. And then we don't want to forget about our config object for tracing. There we go, and that will generate the title text in the LLM. Next, we're going to want to use this title entity that we saw earlier. We'll open it to the side. And specifically the from string method, which will extract the title. I'll go over this function in a second. But first, this is something I noticed that would only happen with the title generation call and nothing else, where the LLM wouldn't respond with the different prefixes and suffixes that we wanted. So we have to do a manual check where we'll say if title text does not end with title element, or sorry, not title element, the end marker as we can see, we're passing that into the extract element as the ending, as the end arg there. So if it does not end with the end marker, then we want to modify title text just like that, so it ends with the end marker. After this, we can go and extract our title, but there are two more things we need to do. Sometimes it also wouldn't prefix with this, so we need to say let title is going to be of type title, and then we can say if title dot starts with title element. Sorry, not title. We want to do title text. If title text starts with the title element, we can just pass it right in. It'll have the title element. We know it'll have the end marker because of this, and we can extract the text. And then else, we can say, there you go, title from string. We want to make sure the title element is there, and then the title text. And we don't need a space there because it's extract elements. We'll parse it all out for us. And then finally, we can return the title entity and the raw text from the generation. And this will generate our title. So yeah, now we can go and generate characters. Kind of acts the same. We're going to want to take a prompt, generate the text, call from string and the characters entity, which I'll open up here as well. Yeah, so we can kind of just copy this, because a lot of this we're going to be able to reuse. Rename this to characters prefix and characters prompt. Paste that in there, paste that in there. Obviously we don't want the title prompt, we want the character prompt. Still want the storyline, you can see here, but it's not title, so we can get rid of that title element. And then we're passing to our prompt, passing our prompt to generate text, passing other fields in, getting back the const character text, make that plural. And then we don't need any of this because the LLM consistently generates all the different end and start markers. So we can say const characters equals characters plural dot from string, passing in the characters text. And the reason we're using characters plural and not the singular one is because inside of this from string, we call the singular one on all the different elements that are extracted. And a quick note, you can see that inside of the title from string, we only want one title, obviously, so we're just getting the 0th element because this returns an array of strings. But for characters, we want multiple characters, so we're extracting all of the elements, iterating over them, and then for each element extracted, call the singular character from string to format that. If it was able to format it, then add it to the object and return a new instance of the characters class. And then we can, once it's all been formatted, return the characters entity and the characters text just like this. I can type. Nice. Now we've finished our generate characters function and our generate title function. We can move on to the generate scenes. Alright, now to generate the scenes prompt, or the scenes text, we're going to want to first define the scenes prefix. So we'll say const scenes prefix equals that, thank you Copilot, with the scene prompt storyline, and we're going to want to add a new line, because as we can see from the input, we're also taking in character descriptions that we will have generated just before this. So we'll say for const name of input dot character descriptions, input dot character descriptions, if name is true, then scenes prefix plus equals a template string of input dot character descriptions name new line. And this is just going to add the different character descriptions to all. Name in character descriptions. and make this an editable variable. So then we're going to add all the different descriptions to our scenes prefix. And finally, after looping over this, we can append the end marker. So we'll say scenes prefix plus equals a template string with the scenes marker at the end, and we'll new line this just to be safe. And then we can go and generate the text. We'll say const scenes text equals await generate text. And before we forget, we'll pass in the config object, and then we need to define our LangChain prompt. So we'll say const prompt equals, or we'll match conventions, scenes prompt equals chat prompt template dot from messages, passing in our system default and the human prompt with the scenes prefix. Let's pass this into our generate text. So we'll say generation prompt, scenes prompt, LLM config, done. And now we can call the scenes entity to parse this text and actually extract our scenes, which we've made up of the singular scene entity, and then it'll contain a place, plot element, and the scenes beat. So we can say const scene equals scenes dot from string scenes text, and finally return our scenes and our scenes text. So return scene and scenes text. There we go. Now we have defined our scenes function. Our generate scenes function takes in the character descriptions as we defined from before. It creates our prompt, including all the character descriptions, the scenes prompt, and the scenes marker at the end, which is just scenes. And if we look inside of our prefixes, scenes marker, we can see that it's defined before this list of example scenes, and then we're going to be adding in our storyline characters and then that scenes marker as well, so that LLM will know to generate the rest of the scenes based on the example that we passed to it. And yeah, that's the rest of our generate scenes function. Now we have place descriptions and dialogue. Alright, now for our place descriptions, we're going to want to see, or as you can see, we take in our scenes that we generated before, and we're going to use these, and we're generating the descriptions for each place. It's going to compound. We're going to pass in each scene description to the next LM generation so the story can progress in the proper way. So we'll first define our place prefix, where we'll say const place prefix equals template string. We're going to want to get the setting prompt and the storyline. And then next, we can go and get a list of all the unique scene names. So we'll say const unique place names equals, and then a new set, and that looks right, where we're going to take the scenes and then the scenes property on that scenes entity, and then the actual place name from each one of those scenes. And we'll convert this back to an array by doing this, just so it's a little bit easier to work with. And now that we've generated our unique place names, we can define a place descriptions object, which we will then go and append or add places to after we generate them. So we'll say const place descriptions, just like that. And the key is going to be the name of the place, and the value is going to be the place entity. And now we can iterate in a for await loop, because we're going to be calling an async function inside there over each unique place name. So we'll say for await const place of unique place names. And now that we're inside here, we can take the place and create our place suffix. We'll say const place suffix equals, and then we're going to use the place entity dot format prefix. Sorry, place prefix. This format prefix with the place name. And now that we have our place prefix, we can define our prompts. We'll say place prompt, just like that. But we want this to be a template string with our place prefix, and sorry, this is supposed to be suffix, because that's the prefix. So const placed place suffix. And we want to get our place prefix that we defined above and follow that with the place suffix we just defined there. And now we can generate text. So we'll say let place text equals generate text, await generate text, passing in the prompt lm and seed, and don't forget config object. And now we've generated the text using our place suffix. And if I can quickly show you what this is doing, we're taking place format prefix, and that takes the place element, the name which we passed in, and the description element, and it's once again more prompting so that the LLM can see this is the place name. Let's write the description. And now that we have the place text, we can go and format this. So we'll say, we'll reassign this saying place text equals a template string with the place suffix and place text, just like that. And then we can use the place class, and we'll say place descriptions with the place name as the key, and place.fromString, passing in the place and the place text. If we see from string takes in the place name and the generated text, then trims the name, adds the end marker, and extracts all the places in between the description element, which is what we appended with the format prefix, and the end marker, which we just added there, and we'll just get the first one and return it. Now we can push this to array, so we will forgot to define this here, so we need to say const place prefixes equals an empty array. And now we can push our place prefixes there. That's what we're going to use to return here with just our plain text. Or sorry, not just our plain text. We want a template string with the place suffix and then place prefix. So place prefix and then place suffix. There we go. And place suffix is generated each time based on the place. And when this is all done, we can return our place descriptions, our array of place prefixes. And now our generate place descriptions function is finished. If we go through this one more time, generate the prefix using the prefix passed in, storyline. We're going to get an array with unique place names. We don't generate place descriptions for the same place twice. We defined our object here, which we will append to once we finish generating, and then we iterate over each unique place name, generate the suffix using the place format prefix method, which just adds these different constant elements, constants. Construct the prompt, pass it to the generate text function, reassign this text with the suffix, call the fromString method, which uses the extract elements function to extract the different place descriptions, append it to the object, push it to array, return everything. And now we just have to generate the dialog as the last function, and then all of our generate functions are done, and we can move on to writing the actual story generator and some nice utils to go along with that. And then we define our graph, and yeah, see how it works. Alright, so for generating the dialog, first we're going to want to go and implement this prefix summary util, which we have the outline for, but not the actual code. And the prefix summary util is essentially going to take in a storyline and a list of scenes, and it's going to use the constants that we see all over the place and return a string with the summary prefix. So first we're going to say let summary equals template string with the summary element constant and the storyline with a new line, and then if scenes.length is greater than 1, we're going to want to say summary plus equals another template string with the previous element constant, scenes.length, the second to last, but with the beat. And this previous element says previous beat. I'm writing the beat here, and it's the second to last element for a reason which we will see when we implement the generate dialog function. And then we can just go and return summary. Return summary. Now we've implemented this. We can go back to our generate function, and here we're going to use that to generate the different prompts and generate the dialogue. So first we're going to want to say const scene equals the last scene input.scenes.length -1. And this is going to give us the last scene, and then next we can say let place t. We're going to have a bunch of variables, so we're going to have the t at the end, equals place element new line scene.place with a new line. Okay, so now once we've defined our place t function, we're going to want to add a check, and we're going to say if the place from the last scene is in our input.place descriptions. So if scene.place is in input.place descriptions, then we're going to want to extract that place description. So we'll say const place description equals the place from place descriptions input. And then if this is true, we need this check, we can say place t equals a template string, and this template string is going to contain the constant description element, and then the place descriptions dot description, and we're going to want to add a nice new line at the end there. And now we've defined our place t variable for the prompt. We can go on to building the characters prompt. So we'll say let characters t, and then we'll just give this a empty string. And then for each of the place descriptions passed in, we can say if object.values length is true. So if we have some input.place descriptions, we can do characters t plus equals the characters element constant, which is just characters colon, and then we can iterate. So we can say for const name in input.character descriptions, and then we don't want this, but we can say if scene.beat includes the name, then we can modify our characters t with the description name and a nice new line. And now we've constructed our characters prompt. And the last one to do is to put them all together into a final prompt. So we'll say const plot element t equals template string with the plot element constant and the scene dot plot element and a new line. Next we can say this, we want the summary prompt, so we'll say const summary t equals, and then we're going to go ahead and use our prefix summary function before, so we're making the summary element now. And this takes in storyline and a scenes, so we'll say input.storyline and input.scenes. And now we have our summary string, and finally the beat, const beat t equals the beat element and scene.beat with a new line. And now we can kind of put that all together in a const dialog prefix equals one big template string. And this is going to be the dialog prompt, the place t variable or string we defined here. Characters t, let's do this. So, want to do the input prefixes dot dialog prompt, and then the place t, characters t, plot element t, summary t, beat t. We're going to finish this all up with a new line and a dialog marker and a new line, and this is so the prompt knows to start the dialog. Because if we look here at our dialog prompt, we can see that dialog marker, then it starts to define the dialog, end marker. So us adding the dialog marker here will tell the LLM, hey, it's time to start writing the dialog and finish with the end marker like it saw in the prompt here. Now we can construct our LangChain prompt. So thank you Copilot, dialog prompt with the system default, dialog prompt, and then we can go and call generate text. So const dialog text equals generate text. Let's pass in our config object before we forget. Our generation prompt, seed, and LLM, and then we can return it all. So we return a string and a string, which is the dialog text, and the dialog prefix, which is this nice big prompt we just defined. And now that we've finished this, we can save to fix these inputs, and we have now defined all of our different generate functions. And because we have all of these finished, we can go to our story generator and start implementing the step method, which we'll use in our graph to generate each step, aka the title as the first step, characters, scenes, places, and so forth. Alright, now for the step method, what we want to do first is implement the strip end util function. We're going to use this pretty frequently throughout this step method. So what this is going to do is it's going to take in some text and the end marker, and it's going to strip the end of a string if it ends with an end marker. So it's first defined a editable text variable because some nice ESLint rules around reassigning text args. So let editable text equals text dot trim, and then we can say const trimmed end marker, and it's going to trim the end marker, which shouldn't need to be trimmed anyway, but these are you are able to customize these, so we want to make sure. And then we want to say if editable text ends with the trimmed end marker, reassign it with substring 0, and then the length of the editable text minus the length of the end marker. So it's just the text without the end marker. Finally, return editable text, and there we go. Our strip remove end function is finished. And now we can go back and start using this throughout our step method. Alright, so for the story generator, first I'm going to walk through this class and the methods already implemented, and then we're going to implement the set storyline method. So this is going to be the main class, which handles the generations, handles keeping track of things like the scenes, the places, the dialogues. As we can see, we already have all these class properties here in a constructor, which takes in 3 required args, the LLM, which is going to be Chat Anthropic, storyline, prefixes, and these are going to be the prompts, which we saw earlier, the storyline, which is your logline or initial short description of the story, and obviously the LLM. The constructor then sets these fields or class properties, and it initializes the different title, characters, scenes, properties with empty string entities. And then it calls this set storyline method, which we can implement right now. So what this is going to do is it's going to set the initial level and storyline class properties. So we're going to say editable storyline is storyline.trim, and then if editable storyline does not end with a period, we're going to want to add that just for consistency. So editable storyline plus equals the period, and then we can set the storyline, so call this dot storyline equals storyline, and then to keep track of the level we're on and this interventions method we have right here, which we will not actually use in this example, but there are some other methods that you can implement from the original Dramatron. It's not in this repo, but I will add it before the end. The original Dramatron notebook, and allows you to kind of step back, recreate a title, recreate a character, or whatnot, and that's what this will be useful for. We're going to set it anyway, so we're going to say this dot level equals 0, starting the 0th level, 0th level, and then this dot interventions. We don't want to get a timestamp, so we know when we started. So const timestamp equals date dot now, and then interventions at the current timestamp equals storyline with the editable storyline. Boom, and then we're done, and our set storyline method has been implemented. So when you call it the constructor, it's going to set the level to 0, going to set the interventions, going to clean up the storyline, and set it on the class property, or set it to the class property. Next, this getStory method, which is already implemented. We're going to use this inside the graph when we're generating the story at the very end. What you do is you call it on the class, or you use this class to call it. It gets character descriptions from the step characters, calls this util function, which one exists in each of the entities, which essentially just takes in an instance of the character's entity, returns the descriptions. It's a little bit cleaner than calling character.character descriptions. So it gets the character descriptions, and then new story, which is also a class which comes pre-implemented. It's kind of just a placeholder for these different entities, which we will use, or which is used inside of this render story function. See, it takes in an instance of the story class and then renders it nicely. So this class just kind of holds the storyline, the title, the character descriptions. Could use like an object that's typed with an interface. This is just a little bit easier because you can initialize it like this, and it's done the same way that they do in the original Dramatron notebook. And then this returns an instance of this story entity, which you can then use to render the story here. So we will use this all the way at the end when we've defined the graph. Won't do it now. And yeah, now we can start implementing the different steps. Generating the title, characters, scenes. Yeah. Alrighty, I had to move rooms real quick, but now I'm back and we can implement this step method. Okay, so as we can see, it takes in 4 args, level, seed, index, and the config object. The first thing we're going to want to do, or let me restart. At a high level, this step method is going to have an if-else chain, which is going to check if the level equals 1, 2, 3, and depending on which level it is, it's going to either generate the title, then assign those class properties, or generate the characters, assign those class properties, and so on. So the first things we're going to want to do is do some checks around the level that it gets passed in, because we're just allowing a number. So we're going to want to assign it to an editable variable. So let editable level equals level, and then if it's undefined, we're going to assign it to whatever is already on the class property. Next, we can say if editable level is less than 0, or it's greater than or equal to the amount of level names, then we're going to want to throw a new error. So throw new error invalid level. And then finally, we're going to want to assign this dot level. We're going to want to add 1 to the level, and then assign it to the class property. And next, going back to this interventions class property, we're going to want to add a new one because we're taking a new step. So get a timestamp, and then this dot interventions at the timestamp, and we're just going to say step with the current step that we're on. Boom. All right, now for the if statements, pretty simple, right? We're doing if editable level equals 1, then we'll just add console logs for placeholders right now, generating title. Else if it's 2, generating characters. Else if it's 3, generating scenes. If 4, generating places. Else if 5, generating dialogues. Then else console.log. Done. All right, so now we can go through one by one, implement each of the different levels for title, characters, scenes, places, dialogues, and so forth. They're all pretty simple. We're going to want to say const title and title text equals await generate title. And then we're going to pass in the args that this requires, which are storyline prefixes LM and seed. So, oops, it's an object. Storyline we can get from this dot storyline. Prefixes, this dot prefixes, LM, this dot LM, and seed from the passed in seed object. And this is going to give us the title entity and the raw title string. And from here, we can assign the class property of title to the title that was returned. This dot prompts dot title to the title text, which is the raw title text, and prompts are here, which are just the results of the prompts that we generated. So after we've done this, we can update the interventions, timestamp, title, title. Boom. And this gives us the different, we don't want it, we want to append to the title. So plus equals title, title, to string. We're going to use the title element, or the title entity, in the toString method, just so we get all the different properties from the title entity and not just the raw generated title string. And finally, the step method returns a Boolean, which is if the title or characters or whatever you asked for it to generate was successfully generated. So const success equals title dot length greater than 0. So if there are more than 0 characters in the title, success, we did it. And then we can return success. Boom. And now we have finished implementing the first level, which is to generate the title. All right, next for the characters. It's pretty much the same as title, but swapping out the different inputs. Let me move this out of the way. All right, so we can paste that in. We're going to want to generate characters instead. Storyline prefixes, as we can see, takes in the same input. Storyline prefixes seed LLM. Almost forgot. We need that config object, so we get proper tracing. Don't forget that. And then we can get the characters and characters text from generic characters. Assign this to characters equals characters. This dot prompts dot characters equals characters text. And then we'll say characters equals characters dot toString, which is that, characters dot toString is the toString method on the characters entity. And then finally, if characters dot character descriptions if we have more than 0 character descriptions, we know that we successfully generated the characters and we can return success. Now for scenes, we can paste that in. We're going to want to do generate scenes. This has a slightly different input schema because we need the character descriptions that we just generated, but it's still storyline prefixes LM seed, storyline character descriptions from this dot characters.character descriptions. You know what, actually, we have a nice util for this. Characters, get character descriptions. We'll use that util. Passing in the config, boom. And now we can say scenes and scenes text. We can see that's a string. Scenes entity. This dot scenes equals scenes. This dot prompt dot scenes equals scenes text. Scenes. We should probably add a new line to the end of these just for better formatting. So let's add these new lines. All right, and now once again, we can use the toString method on the scenes to convert the scenes entity to a nice string for our interventions with a timestamp. And then to check if it was a success, we can just say scenes dot num scenes is greater than 0, success. And there we go. Now we've finished implementing our scenes, characters, and title steps. You can add some nice comments saying generate the title, generate the characters, and generate the scenes, just so when we go back we have a little better idea of what's going on. Let's add some spaces too, which makes this a little bit easier to read. There we go. And now we can move on to generating the places. And then we'll just have dialogues and then we're done. Alright, now for generating the places, kind of the same as above, we can just copy this with some slight modifications. So we'll say places and places text. And then we're going to want to do generate place descriptions. Put that over there. We see that it takes in storyline, scenes, which is new, so we can swap out scenes for the scenes class property. Prefixes lmseed, config, don't forget. And let's add a comment. Generate gen the place descriptions. Alright, and now we can assign this to the class properties. So assign places to the places property and prompts.places to the places text. Alright, and now we're going to want to update the interventions like we did see here, but with the different places. So we can say for const place name in places, and then if place name is true, const place equals places place name. This is going to be the place element. So then if place is true, this dot timestamp place dot toString. Add a new line. Boom. Okay, and finally for returning success, we're going to say const num scenes equals this dot scenes dot num scenes, and then const success equals object dot values places dot length. And we want to make sure this is the same as the number of scenes, and num scenes is not 0. And then we can return success. And there we go. We have implemented our 4th level where we generate the place descriptions, assign that, update the interventions, and return success. And now we can go on to generating the dialogues, and then we can generate the graph, or write the code for the graph, and see this all work in action. Alrighty, for the dialogues, let's add our comment. We'll say generate the dialogues, and then first we're going to want to extract the characters, scenes, and places into variables, just to make it a little bit easier to work with. So const characters equals this dot characters, this, or const scenes is this dot scenes, and finally const place descriptions equals this dot places. Nice. Now we're going to define dialogues. Oops. Const dialogue prompts equals an array, and we'll type this as an array of strings, and also an array of strings. And that's so we don't get the TypeScript error like cannot assign whatever to type never or array never. Yeah, and now we can say if idx equals undefined, and that's part of the input here, kind of an advanced Dramatron feature for going backwards and forwards. And we'll implement the logic. We won't actually be demoing that. Else to do implement. All right, so now here we're going to want to generate dialogue for every scene. So we can say const results equals await promise.all, and then map over all the scenes and call the generate dialogue function here on each scene. So scenes.map. That's going to be async scene. I don't think we need that. I think we can just do generate dialogue, and generate dialogue takes in storyline, scenes, character descriptions, place descriptions, prefix, LLM, and seed. So storyline is the same, so or same as the other one. Storyline is this storyline. Scenes, we're going to want to pass in only the net amount of scenes that we're on with our map. So scenes equals scenes dot slice 0, k plus 1, and this is so we only pass in context in the scenes, which it either has generated, or if it's the first one, just the first scene. So it's not looking ahead at scenes, which it has even generated dialogue for. Next, character descriptions are characters, which is the same as, or which we get from this variable, equals characters dot character descriptions. Next is place descriptions. So place descriptions, we already have that variable. Prefixes, this dot prefixes, LLM, this dot LLM, and finally seed. And now we have our array of 2D arrays, and we're going to want to reduce over these and assign that to our dialogues and dialogue prompts variables. So we'll say dialogue and dialogue prompts equals thank you Copilot here, and let's see if Copilot can get the rest. Yes, perfect. And I think we need this to start. Why are you complaining? String is not assignable to property never. String never. We need to type it. So we're going to want to say string array and string array. Did I type that incorrectly? Oh yeah. Inside of this 2D array. There we go. Because we're returning an array with arrays and arrays. And that's going to assign this to our variables up here so we can iterate over our return results and update this dialogues prompt. And then for this, we're not going to implement this in this video. Don't need to, we're not going to use it. But essentially here you would generate dialogues for the amount of scenes based on if you've already generated some scenes. But yeah, we don't need to do that because we're not actually generating those scenes just now. Let's see. This dot scenes, let's make sure we do this all right because we're not using this variable. Which would actually make sense because we're mapping over and then we're slicing it there, so I think make the linter happy, make it an underscore. Yeah, and now we just need to return success, or assign the class properties if we're able to generate them all, and finally return success. So we'll say this dialogues equals dialogues, this prompt dialogues equals dialogue prompts, and then get a loop over everything. So for const dialogue of dialogues, get it, update the interventions, and then return true. We have succeeded. Nice. Where are these errors coming from? This is an error. If you get here, we don't support other steps. We got to throw, so throw new error invalid level, and then we have one more, which is just for the imports. All right, now we can go and implement the graph, which is going to use LangGraph. It's going to call our story generator, loop over that until it's generated all the stories, render it, log it as a nice text string. All right, so last but not least, we want to implement our graph. We're going to use LangGraph for this. It's essentially going to have a few different nodes, for generating the different dialogue or characters, deciding if we need to continue, verifying that everything is done, generating the fancy text, and logging it. I'm just going to copy and paste this log line in that I pulled from the Dramatron repo, and it was their demo of what like a log line to use, generate a story, and we start implementing the graph. So first things first, I'm going to define a type that will represent the graph state. So we'll say type graph state equals, and then what do we want to pass in? We want to pass in a log line string, which we'll pass in initially. We're going to pass in an LLM. Actually, we don't need to pass that in. We can just access that globally. That does not need to be configurable. And then inside the graph, we're going to pass around a story, which will be of the story entity, or null, because this will be null for almost every iteration till the end when the story is finally generated. Prefixes, which will be of type prefixes. We will pass this in, so it does not need to be null. And these are the different prompt prefixes that we're going to use throughout the generations. What else do we need? I have it written down over here. The level we want to start on. Level number. This is always going to be 0 for us. However, you could pass in 3 if you want to start generating at, let's say scenes. But for us, we're always going to pass in 0, but it's good to make it customizable. And then finally, generator, which will be of type story generator or null. We're not going to pass this in. However, we're going to initialize it on the first node and then pass it through, so it's going to be included in the state. Alrighty, now we can define our graph state channels that we're going to pass into our state graphs. We'll say const graph state, and this is some LangGraph syntax, so we can kind of just copy this all in. Each channel takes in a value, which we are going to default to null because we don't need a default, or sorry, we're going to set it to null. You can add a default, which is just a generator function which returns something that the default will be. And for value, you can make it a function where every time you return that in the state, it calls this function. So let's say you're doing an array, you would take an A and B, which would both be arrays, and then you could like concat it, and that way you could return just a single element of the array and not the entire state, and LangGraph will handle updating that so it always stays in sync. But for us, we just need to be null, and we can do this for each entry. So paste, 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 and paste. Nice. Now we can define our LangGraph instance. We're going to give it a variable name of workflow. It's just a convention we use in a lot of the LangGraph docs. It's like your graph workflow. So const workflow equals new state graph, which we can import from LangChain / LangGraph, and then pass in our channels, graph state, and just to be extra fancy, we can pass in a generic for the graph state right there. Nice. Now we've defined our workflow. We can go and define our LLM. So const LLM equals new chat Anthropic. Model name is, oh yeah, what is it? Okay. Anthropic models. I'm going to figure out the API name and then come back. I already found it. So for this, we're going to be using Sonnet. That's their smallest and smartest model they have available right now. I would recommend using Haiku when it does release. Hopefully it comes out soon, just because it's going to be cheaper for you. It's smart enough to get the right results and a lot faster. That's what they claim. So for this, we're going to use Sonnet because Haiku is not available. So model name is that, and set the temperature to 0. Nice. Okay, now we can define our different nodes. The first will be the initializer node, so const initializer node equals state graph state. And this is the nice thing about LangGraph. Each node gets the entire state as an input. However, you don't have to return the entire state each time. So let's say we take in the entire state, but I only return the generator. It's not going to lose any of the other state items, even though I didn't return them in that node. So we only need to type this as returning a partial. And here we're going to want to define the story generator class. So we can say const generator equals new story generator. Let's add, oh, that sucks. Why VS Code? Import story generator from, it's because we've already imported it because we use it as a type. That makes sense. And then this takes in an LLM, a storyline, which will be the state.log line, and the prefixes, which will also be from our state. And then I believe we can just return our generator like that. And then this will get passed to the next node. We won't have to initialize it again. We can go ahead and, no, we will add our workflows later. So next we're going to define the generator node, which is going to iterate on the levels and call the story generator step function. So const generate generator node, or we'll call it generate node. Generate node equals the state, and it's going to return a partial. So we will say const generator equals state. If generator is false, we're going to want to throw, because that wouldn't make sense. Throw new error, generator not initialized. Now we know that it's going to be defined. So we can say const success equals await. We need to make this async, and then type this for a promise. Nice. Await. Nope. We're going to want to await the generator dot step, and we're going to want to pass in the level, and we don't undefined. We don't need to pass in those. But we do need to pass in our config object, and here we forgot to define config as runnable config, make sure that I get imported from the right path. Yep, LangChain core runnables. And the reason we don't need to include this in this state is because LangGraph is a LangChain open source project. Every time this node is called, we're automatically going to pass in config as the second object. So if we define it, that's enough. We don't need to include it in the state or anything because LangChain or LangGraph will pass it through every time. And now we're passing our level and our config. And then we can, if this is successful, then we want to return the level +1. And if it's not successful, we want to return the same level. So if success is true, return level as state.level +1, and else, nope, we're going to want to return level as just state.level. In this way, when we define the next node, or not a node, it's going to be a checking function. We'll check to see if we need to advance to the finish line or keep going. If we need to keep going, it's just going to call generate node again. The level's going to get passed in. It'll either advance to the next level or retry. There's a built-in maximum retries to LangGraph, so this will time out if it keeps failing. We don't have to deal with that. However, you can update it. It is configurable, so if you want it to be less than, I think it's 25 is the max right now, then you can change it to be 2. Well, don't do that because then you won't be able to complete. You could change it to be like 10 or 12 or 50, depending on how many retries you want. But most of the time, this is just going to succeed. It's going to advance to the next one, and then we can define our should continue check. So const should continue. And this is going to essentially check to see if we need to keep generating or if we can go to the render story function. So const level equals state, and then we only care about 5 levels. Yeah, 5 levels. So if level equals 5, return, what are we going to call it? We'll call it render for rendering the story, and then else, or render node, and then else we will return generate node. We'll do greater than or equal, just so if something goes wrong we don't skip over it. Yeah, and the reason why we can return a string here is because when we define this should continue method, LangGraph will take whatever the string is that's returned, and if a node exists with that name, it'll call that node. There is a way to return another value and then map it to the node you want to invoke, but this is simpler and more concise. Nice. Now we can define our render story. That's not right. We'll just do it ourselves. Okay. Const render node equals, we don't need async, state graph, and then we can say const generator equals state. We can get the same if statement there. If it's false, throw, and then story equals generator dot get story, which is the method which was already implemented. It essentially just returns a new story entity, and then we can return story, and that will apply there. Nice. Now we can define our LangGraph nodes. So we'll say initializer node is going to be called initializer node. Generator node is generator node. Should continue will not be a node, but we do need render node to be one. So we'll just copy and paste that. Nice. Okay, now we define our nodes in LangGraph. These are different functions which can be invoked by the graph, which can go back and forth to each other. And we need to find our starting place now. So we can say workflow.add or set entry point will be the initializer node. Workflow.add edge. Initializer node to generator node. This essentially says LangGraph should always start with the initializer node, and then after finishing the initializer node, it should always call generator node next. And then we want to add a conditional edge for generator nodes, so workflow.add conditional edges. And this is going to take in a start key and a condition. So that'll be the generator node and then the should continue node. What this says is after the generator node finishes, call should continue, and then should continue either returns the name of a node or the name of a different node. Or you can make it return some keywords like end, which is exported from LangGraph, so you could say end, and this is a constant where if LangGraph sees this, it'll automatically finish the chain. We're not going to do that here because we can set a dot add edge. Nope, because yeah, we don't need to add an edge for generator to render because our should continue will handle that. But what we do need to add is a finish point render node, which says that if should continue returns render node, because the level we've already completed all the levels, then it'll call render node, get our story, return it to state, and finish. Nice. Now we just need to compile the app. So we'll say the graph const app equals workflow.compile, and then we can invoke it. So we're going to stream this just to make it a little better, a little nicer UX. So we can say const stream equals await app.stream. We'll pass our args in a little bit later. And then we can iterate over the stream. So for await const state of stream. Here, this is going to be an object where the key is the node we're on and the value is whatever was returned from that node. So we can say const key value equals object.entry state. Let's grab the 0th item. And then we can do some nice logging. Console.log, new line, console.log. We'll just say key, oops, and then value, but we'll comment that out. We don't really need to see that. We should add another check here. Okay, yeah, so going back to the end variable or constant I mentioned, this will always be the key of the last node. So we can say if key equals end, we're going to do something a little bit different. We don't need to log that. But if it's not the end, then we want to log. And here we can say let final result. And we can say final result equals value. Beautiful. And then finally, we can console.log our final result to see the final result. Nice. Okay, yes, the last thing we need to do is pass in our values to stream, which we defined as the log line, the prefixes, and the level. So level will always be 0, at least in our case when we're starting. Log line is that constant, and then prefixes we can import from our prefixes. So we can import prefixes. And then we're going to do this one. So nice. And this is going to be prompt prefixes. Sorry, I mistyped this. We only need to set this to a string, and I will show why in a second. We set that to a string because inside of story generator, inside the constructor, it does that mapping for us. So we pass in a string, and then it maps that to the proper prefix and assigns it to the class property. Nice. This all looks good. I'm going to pause this, set my environment variables, and then come back and we'll run it and see what it actually looks like in my terminal. Alright, I've set my environment variables. I added my Anthropic API key and then also my Langsmith API key. and that's so we can see get all the tracing. So now we can go and try to run this. So we'll navigate to the backend directory. We'll say yarn start, hit it, and 400 error. Roles must alternate between user and assistant, but found multiple user roles in a row. Interesting, interesting. I believe this is because if we set that, before it was just doing a from template, which assigned a default role, and I think for Anthropic, the default role is a human role. But if we set this to system, it should start with a system, please. Yes, okay, so now we're calling the generator node once. It's going to generate. Might take a second because Sonnet is a little bit bigger than their, or a little bit slower, I guess, than something like GPT-3.5 or hopefully Haiku when it releases. But you can see it's moving kind of quick. Yeah, so we've gone through 3 generator nodes so far. Should be 5 total. Then it'll log everything. I forget the exact output, so we're going to run this one more time once we see what the value of the end is, so that we can call the render story function on the story. I guess we could have just logged that there, but it's a little bit nicer if we can do it at the end. Now we've done 5 generator nodes, or we're completing the 5th, and when this finishes, it should pretty instantly map to the render node and then log. Okay, so I canceled it. It says pending in LangSmith because it doesn't realize it's being canceled yet, and we can actually debug why this was not completing. So we can see it generated the first one, which should be a title. Gave us a nice title. Second, gave us our characters. That looks right. Third should give us our places. Fourth should give us, okay, so it looks like it's getting caught up on places. If we then go here, we see level 2. It's obviously not updating because it wasn't happy with that success. So generator node, just make sure it's still only able to get through places. Wait a minute. Yeah, so it looks like it's adding some extra text we don't want. Still places, we go to the last one. I canceled it halfway through. Okay, so what we can do is add some more logging inside of our graph, or sorry, inside of our generator. So if we go here, let's open this up a little bit more, and we'll say we'll just add console logs to each level so we can see what is failing exactly. And then I guess we'll also add an if statement saying if success is false, we want to log exactly what was the raw text and if it was able to parse it out. So I'm going to add that and come back in a second. Alright, so I add this little check to each of the levels except for dialogue. We never made it there, plus it'll always return success, so we don't need to check there. But essentially what this does is, it says, pretty self-explanatory. If success is false, it's going to log title success false or character success false, and then the hopefully the extracted entity, but it probably won't be extracted if it's failing, and then the raw text is returned from the LLM. So now we can go back here, we can rerun, and then when this starts to fail, I will kill it, and we can try and debug from there. Alright, so as we saw last time, it's failing on scenes, and it's unable to extract a list of scenes, but it obviously is getting the text. So we can go to generate scenes. We can then go to the from string because we know that this is getting generated, and we want to see what is trying to get extracted. So we're just going to log all of this, console log it all, and then see what, if any, are not getting extracted. All right, so running it again, it looks like it was just the model being a little unpredictable, because we can see it generated the scenes here. But now if we look again, it's failing to generate the descriptions. So we have our system prompt, our prompt here, location description for a given log line, and it's just iterating on these over and over. It's not able to generate. So what we're going to do is the same console log debug process, where we go look at our generate text for unique place names, and we see what's going wrong and why it's not able to continue. So I'm going to add console logs, I'll rerun it, and then I'll come back and I'll show you what it logged and kind of the debug process around that. Alrighty, I'm back. The issue ended up being here. When we get the number of places, before I had it at get number of scenes, because I saw scenes, get number of scenes, wrong. That is not what we want to check. We want to check num places, and then make sure that the place descriptions matches the amount of places. We don't care if there's the same amount of scenes as places. That doesn't correlate at all. We want to make sure the number of places, we've generated the same amount of place descriptions as there are places. So when I update this, it works. Let's run it again. Oh, also, while I was debugging, very exciting, Anthropic released Haiku, which is their smaller model around GPT-3.5 knowledge, knowledge-wise, but also half the price for input tokens, and I think 25 cents per million tokens cheaper on output tokens, and I think it's supposed to be faster as well. And I mean, from running this, you remember you were just seeing how fast it was with Sonnet, and now if we rerun with Haiku, I don't even need to pause the video. It's just gonna whip right through it. Generate. I mean, this is maybe 5,000-6,000 tokens in total, and it's gonna get it all done in, oh, this was, okay, so 21 seconds total between everything. That was an error on my log. I thought I logged it properly. Exist. Story definitely does exist. I don't think I need to do, where was I? Graph. I don't need by end, I don't think. Let's try that, and we'll also just console log final result, so we have both, in case story does not exist. And then we can see what went wrong. But this should work. I'm going to pause in between here because 20 seconds is a little long to wait, but I'll be back when this is finished. All right, so that was right. I didn't need to mark it at the end. So when we final result.story, because we're returning the story here, and then we wrap it with this render story util, which comes with this repo, we see this. And inside the render story util, you can update this to have your name, or Anthropic, or whoever you want it to be co-written by. And we see it was able to generate title, description, all of these scenes with places, plots, and beats, and then finally all of the dialogue. As you can see, it's extensive. It was able to generate a lot of text, and if you actually sit and read through it, it's pretty cohesive. So I will include in this template repo a text file called example story right here. And this is from a previous generation, so you can see what the expected output looks like if you're building this yourself. And yeah, just to reiterate what we did here, we use Google's Dramatron, LangGraph and LangChain, and Anthropic's brand new Haiku model to quickly and efficiently, without using function calling, generate an entire play with characters and scenes and you know, a whole dialogue. And without that much code, there's really about 100 lines of code for LangGraph, maybe a little less because this This is kind of placeholder code, really. And then inside story generator, we have the core logic is only about 120 lines as well. And then utils take up and I guess generate 250. It wasn't that much. You know, we got it done in, what was this, about an hour-long YouTube video. So yeah, I hope everybody liked this, and thanks for watching.